Welcome to The Explainer. Today we're diving into this incredible invisible war happening right under our noses in the digital world. We're talking about a new kind of shield, one that creators are using to fight back against AI data scraping, so let's just get right into it.
You know, it's the question that's probably on every creator's mind right now. You pour all this time and energy into making something original, art, music, writing, only to discover it's been vacuumed up by some giant AI model without your permission. It really does feel like a heist, and honestly, in a lot of ways, it is. But that's not where the story ends.
What if? What if you could make your work totally unreadable to an AI, but keep it perfectly fine for any human looking at it? Well, that's the whole idea behind this game-changing new tactic. It's like an invisible weapon in this fight for your own work. Okay, so to really get how the solution works, you first have to understand the sheer scale of the problem. We're going to call it the Great AI Heist. And it's all about that unauthorized scraping of pretty much everything online that's being used to power today's generative AI. I mean, the stakes here for creators are just incredibly high. We're talking about their intellectual property being used without any permission, without any pay. And it's not just about the money. Though that's a huge deal that undermines entire creative industries, it's a massive ethical problem, right? It's all built on a foundation of no consent and no credit.
So how in the world do you fight something that feels so massive, so unstoppable? Well, you build a shield. But not just any shield, you build an invisible one. And this is where this absolutely brilliant idea from AI security research enters the picture.
It's called adversarial noise. The best way to think about it is like a carefully engineered digital static. These are tiny, almost microscopic changes that get added to a file, an image, a song, a piece of text, that you and I would never, ever notice. But for an AI? Oh, for an AI, these tiny little changes are more than enough to completely confuse it.
So take a look at this classic example. An AI model is shown an image that, to any human, is clearly a panda. But after adding this invisible layer of noise, the very same model becomes 99% sure it's looking at a gibbon. It's basically an optical illusion that only a machine can see.
And that right there is the magic of it. To our eyes, the original panda and the poison panda look identical. That noise is just some subtle statistical fuzz, but it's designed specifically to exploit the little mathematical shortcuts and weak spots in how these AI networks learn to see the world.
And this isn't just for pictures. The exact same idea works on audio, and honestly, the results can be even more shocking. A person hears a totally normal voice command, right? What's the weather forecast? But an AI, like Mozilla's deep speech model, hears something wildly different after those invisible tweaks are added. Delete all my files. It just goes to show how this tech can turn something harmless into something totally toxic for a machine.
Okay, so the concept is obviously super powerful, but how are creators actually using this shield to protect their stuff? Let's break down the techniques for writing, for audio, and for visuals.
When it comes to text, the changes are all linguistic tricks. You can do things like swap out letters with characters that look identical. Those are called homoglyphs. Or you can just swap out synonyms or change up the sentence structure. A person reading it won't notice a thing, but for an AI that's trying to learn from the statistical patterns, these tiny shifts are enough to poison the well.
For audio, the methods are just as clever. They basically exploit the gap between how we hear and how a machine listens. So you can do things like mask certain sound frequencies that AI models lean on, but that our own ears just kind of filter out naturally. Or you can make these microscopic little shifts in the timing of the audio, just enough to completely derail a speech recognition system.
And for images and video, the defenses have multiple layers. You've got techniques like feature squeezing, which sounds complicated, but it just means reducing stuff like the color depth in an image to get rid of the subtle data that these attacks rely on. And video gets even more interesting because you can use temporal attacks that subtly mess with the sense of motion between the frames. It completely confuses any AI trying to figure out what's happening over time.
So all of this sounds like the perfect fix, doesn't it? Well, it's not quite that easy. This technology has basically kicked off a brand new kind of tech arms race, and it comes with its own set of really tough challenges and big consequences for the whole future of creation.
The biggest problem comes down to this one fundamental trade-off that developers have to deal with.
It's this delicate balance between accuracy and something called robustness.
Okay, look at it this way. A standard AI model is great. It's really accurate on normal, clean data. But the second it gets attacked, it falls apart. Now, if you train a model to be robust, to be resistant to these attacks, its performance stays high even when it's under pressure. So what's the catch? Well, its accuracy on just normal, everyday data can actually go down a little bit. That's the trade-off.
This arms race throws up some major roadblocks. First off, making models robust is just way more expensive. We're talking 3 to 10 times the computing power. On top of that, the attackers are always adapting, always finding new ways around the latest defenses. And finally, all of this is technically really complex, and it requires a kind of specialized knowledge that most individual creators just don't have access to.
So where's this all going? Well, the future is probably going to be a mix of different strategies. We're already seeing collaborative defenses where creators can share data about new threats. We're seeing new regulations like the EU AI Act that are starting to require this kind of robustness. And, we might even start seeing these protections built right into the hardware of our cameras and our mics, creating a shield right at the source.
And all of this leaves us with one last, really fascinating question to chew on. For centuries, copyright has been a legal thing, something enforced by laws. But as technology starts to move way faster than regulation can keep up, are we moving into a new era where the best kind of protection is actually technical? In the age of AI, is making your work invisible to machines the new copyright? It's a pretty powerful idea to think about.